I know I would have gone if it were up to me, but thank you. I'm glad to have you here. So hi, I'm Tyler. We'll get more into introductions in a second, but this is my presentation mostly on how Diplomat, that's the Rust library, how we can take all of this information that we have in Rust, and especially in ICU4X, and translate it into different languages. So that's how we take, the little bits in Rust and translate it into, say, JavaScript, C, Dart, Kotlin. We'll get more into the specifics, but for right now, let's do introductions. Hi. Again, I'm Tyler. I'm here mostly as a representative for Diplomat, but I'm also a computer scientist and a little bit of an applied mathematician. I'm mostly here as a contributor from Google Summer of Code. So I did, I think by my estimations, roughly 500 hours working on Diplomat. I am here to talk to you about Diplomat, how it works, the specifics therein. So yeah, I'm very excited to talk about this library because there is a very key reason that we have it. And I'll get into the sample problem. So I have a pure hypothetical for everyone involved. Let's say we're building a library with a really large scope. And I don't know, let's say it's about internationalization, like anyone would ever make a library covering that, right? So there's a lot involved in making an internationalization library. Let's say, for instance, we have a crate handling conversion between different calendars, or mapping cases in strings, or collating strings, or, oh, wow, look at this. Look at all of these different crates. That's a lot of functionality, and it's all in Rust, right? So obviously, this is not a hypothetical. This exists in ICU4X. We have all of this functionality, and it all exists in Rust, which is nice, but it creates a little bit of a problem, which is one of the goals for ICU4X is portability. Like if we want to embed on, say, different embedded systems versus embedding on the web, if we want to port to all of these different platforms, that creates a problem because we're not necessarily, we need a way to meet people where they're at, right? So that's where we start to run into an issue. And so the naive approach is to say, hey, Rust gives us these sort of external functions, right? We can mark a function as external. We can say, I want you to expose this for me. And then we can link it to our program and then call it from there. And that's a very good way to do it if you know what you're doing. But the issue is, let's say you're not familiar with the language that you are trying to link to. That creates a sort of definition cascade problem. So I have an example to sort of show what I'm talking about here. I have a simple Rust function. It just adds two 8-bit integers together. And let's see how the definition for that looks in C++. We just need to define the function externally. Here, I'll even use the laser pointer here so everyone can see. We have to define the function externally. We have to, in Kotlin, say, load it, and then define it. That's a little bit more involved. You don't have to worry about reading all of this. Dart, there's definition. JavaScript, wow. We not only have to read the WebAssembly, we also have to do some instantiation and some addition. That's a lot. There's a lot that has to be involved when calling each of these functions, right? And it's great if you're already familiar with these languages. I think there's some crackling on the mic. Hold on. Okay, is that better? Anyways, I'm not going to touch it. Anyways, oh my gosh, is this better? I'm going to use this because I don't trust the crackling on this. All right, hi everyone. Maybe if I do it. Sorry, just some technical difficulties with the mic. I don't love this, but we're going to make do with what we've got. Anyways, you have to be an expert in all of these languages. That's my point. Oh my gosh. I'm really annoyed with this mic. Okay. I'm just going to project loudly and hope that everyone hears me. So we have an issue. You need to know all these languages, right? And so on top of that, not only do you need to know these languages, you need to know the associated quirks with calling the functions in these languages. So that's where we have the ABI quirks. So I have an example here I've written out in Rust, and also I have it in C, and we're going to see how it looks compared to JavaScript. So I have this function. It just returns a structure. I've defined the structure in Rust. I've defined the structure in C. You just need to make sure to also define the function in C, and we're golden. I'm curious if there's anyone here who's familiar with WebAssembly and calling this sort of function through JavaScript in WebAssembly, how this works? Show of hands. 1, 2, 3, maybe 4. Well, don't worry, I'm going to show you how it works. It's very exciting. We have to allocate memory, which might be a little surprising because there is not a pointer here, nor here. But the way that WebAssembly works is it can't just return the structure to you. You have to use what's this data view class here to allocate a little bit of memory in your WebAssembly buffer. You have to know the size of your structure. You not only have to know that, you also have to then call the function on that allocated memory, and then, then you have to grab the little bits of your structure out in pieces, like how we call them here. So obviously, that's great if you know how that works in WebAssembly, in JavaScript. But if I'm only passingly familiar with JavaScript and I want to have a structure that's returned, I'm going to be in trouble because I don't know these associated quirks, right? So we can always rely on, say, the experts for help. We have multiple packages that try to make your life easier when you are binding functions externally. So we have CXX and wasm bindgen are two popular ones. CXX is from Rust to C++, and then wasm bindgen is from Rust to WebAssembly and JavaScript. And these work great because they are built by experts who know what they're doing, and you can just set that up and it'll work. The issue is we are trying to port to as many languages as possible. And the work that we are trying to do will just stack up because we have here two different macros, the CXX bridge and the wasm bindgen, and these two aren't really compatible. Like if I wanted the same function to exist across the CXX FFI as well as wasm bindgen, I would have to create two separate definitions. And we want to sort of minimize the amount of work that we're doing. So this is where Diplomat comes in. And this is where this handy little diagram I've created also comes in. The goal overall, as we're discussing Diplomat right now, for the Diplomat library is we want to maximize how many languages we can translate to while minimize the amount of work that the developer has to do when creating these definitions. So from that stems a bunch of design goals. We are mostly interested in having one place to write all our definitions. That's the one source of truth right here. We want that source of truth to then be exported into bindings, and then we want to have those bindings sort of be extensible by language. So once we create a set of bindings, we can then extend those bindings into different languages. Diplomat is part of what does that for us. We also don't just want these bindings, we want definitions to go along with those bindings. Because again, if you're not familiar with the language, you sort of want someone else to have that expertise, create those definitions so you are just familiar with like your corner of the language, right? So let's get a little bit into it. I have here this diagram that I created, and we'll check in on this diagram every now and then as we progress through the slides. But what I have, I don't know why it advanced twice, but what we have here is the Diplomat bridge, and this is where everything sort of starts. So we start out in Rust, and now we are at the Diplomat bridge, which is still in Rust. But the thing that's interesting about the Diplomat bridge, it doesn't just mark this module as exporting everything to then be, you know, for Diplomat to do its thing and export it into different languages. We also set this whole area enclosed by the brackets here to basically be a simplified version of Rust. And the reason we do that is to maximize the amount of translation that we can do. So for instance, C doesn't support generics, Diplomat doesn't support generics because then we can translate easily into C. And this goes on for a lot of different Rust features, but mostly what we're interested in is simplifying the experience of writing Rust, so then you are maximizing the amount of languages that you can potentially translate your bindings into. And so I'm going to give you a little more complicated example to show you a little bit more of what I mean with the bridge. We have here, this is an example I took directly from the ICU4X crate. We have the fixed decimal external definition that we expose. And the thing is, fixed decimal has a lot more going on under the hood in the ICU4X repository. So what we do is we actually link our front-facing structure, the fixed decimal from Diplomat, to our internal fixed decimal. And so you don't need to worry about most of this code, but basically what we're doing is we have more complicated functionality that we are then exposing in some way with Diplomat. And that's the whole point of the bridge. It's just a way for there to be one definition and for us to expose functionality from Rust. Okay, we're going to advance the diagram. So this is where Rust creates bindings for us. We compile the bindings into Rust, and because we have all of this information from the bridge, we can now create the sort of hooks into those bindings from our languages. So we have examples from WebAssembly and C. These are all things that you could do yourself if you want to, but then things start to get a little more complicated. We have bindings from Dart and Kotlin, and because Diplomat supports all of these languages, we now have definitions for those functions that we can just call. But of course, you may recall there was a bullet point earlier that said we're not just interested in bindings, we also want definitions for those bindings. So that brings me to the next part, which is the definitions. We want to meet you where you're at, right? We have all of these different languages that we support, and we want to make sure that you can call them without having to worry about any associated weirdness that comes with just having these functions exposed. So we have definitions for JavaScript, for C++, for Kotlin, for Dart, and Diplomat handles all of this for you. You just need to write the definition in the bridge, and then that's where we get all of these definitions from. It's basically one definition to many multiple definitions in each of these languages. So that's led to some pretty great results for ICU4X. This is where all of the FFI stuff is coming from. We have the C API crate, which basically for any of the languages that Diplomat supports, this is where all of these are stored. So I think we mentioned Kotlin as one we're working to add support for. That's where this will be. And so currently, things are looking very good in this crate. It's also, the support for Diplomat and ICU4X has also led to some great advantages, not just in terms of being able to translate into multiple languages, but also, I have a little bit of fun audience participation. This is where Shane was talking about the WebAssembly demo. So if anyone wants to scan this QR code, I'll leave it up for a minute, and then I will go to the link myself, because we're going to demonstrate how Diplomat made all of this possible. Like, I will wait 1 minute, but you may assume that all of the content we're about to see on this page, that it is made by hand, but in fact, we are procedurally generating all of this from Diplomat. So I'm going to pull this up, and you'll notice there's quite a lot of functions on here. Does anyone have a suggestion for a function I could take a look at? Okay, I will pick one myself. I know let's take a look at the date formatter. There's been a lot of discussion about that recently. I'm just gonna put in some random, I don't think 58 is a possible day. Gonna put in a random series. Oh, it's definitely out of range. I think because I put it in February. That's on me. Okay, but now you know it works because I couldn't type in February 30th. And so the whole point is that any of this is just meant to demonstrate how ICU4X works. So we can move into something else like case mapper uppercase. Uh-oh. Oh, other way. Yes, I forgot. This is actually S is the string. There we go. So obviously I've just typed in lowercase and we've spat out some uppercase. And there's lots more in here. Most of it, I believe, is time zone related, which is great if you're interested in messing around with time zones. We also have this new word segmenter demo that I just added that seems to be, Okay, well, this is the thing about something that's close to alpha, is that there are always a little issues that are inserted, but that's okay. We're just gonna be moving on. Okay, you want me to, which one? Okay. Sorry, which function specifically under? Okay, date time formatter. Okay. You wanted me to put in a weird time? Oh, Hi. Okay. Does anyone? I'm not familiar with TH. Okay. Perfect. And TH. There we go.
Gregorian. Or sorry, like this.
Yeah, that's the kind of U-CA.
Yeah, I want to get it. It's year 2443.
Okay. Perfect. So obviously we have all of this functionality built in, and this is all procedural, right? As you noticed there are some kinks we're still working out, but ultimately, right, what we're interested in is the fact that all of this can be generated from what Diplomat already gives us. So this is where I come in. Hi, I'm Tyler. You might remember me from earlier. And my project over Google Summer of Code was looking at this diagram right here. You might also remember that. And looking at the Diplomat bridge specifically, because there's a part of the Diplomat bridge that it's not just used for bindings. We also have a lot of information about how functions are structured, right? What parameters do they accept? What do they output? And that allows us to do some interesting things because we know from Diplomat what our outputs are going to be, right? And so what's to say we can't use this information from the bridge and the information from our definitions and not make something else with it. And so that's what we have here in the previous slide. And it's what we call DemoGen, which is basically a way of taking Diplomat bridge code and converting it into HTML output for people to experiment with small demos. So I have here, I think this is somewhat out of date, but I have this format time function that I pulled from the Diplomat bindings, or the Diplomat bridge section. And you'll notice we have this Diplomat write parameter here. And that's a pretty nice output section because Diplomat write outputs a string. So we can just grab that string, and now we know anything with a Diplomat write parameter is something that we can then get output from. And so we can also look at other bits of information. So for instance, we have this time value here. We can look at how to create that. I have this constructor function here. And we can look at each of the individual parameters. So I have the hour, the minute, the second, the nanosecond, and these are all primitive types. So I can just grab all of their information from like a number form input, right? And there's other steps that we're missing here, but pretty much any of these functions we can probably boil down into a section of primitive parameters that we can just get HTML input from, right? And that's the whole magic behind DemoGen. We also run into a little bit of an issue with then creating this output because part of the goal of Diplomat is to be extensible so that you're not limited to any one language or way of thinking. So what we have here is we have a way to generate HTML output, but we also want that HTML output to be customizable. So what we do is for every function that we evaluate, we then output its metadata. So what you can actually call to get results, the name of the function, the parameters that it accepts. And so then what you can do is, regardless of your front end, you can then call the function and use all of this parameter information to populate the HTML page. And so we have a built-in default renderer for that, and it too is customizable. I think it's like one of the few things on the web that uses web components to try and maximize compatibility. But if you're interested in making your own front end using all of this information, that's totally feasible. And so from that, what we get is an automatic system for creating demos from your Diplomat bridge definitions. So here we have, I think this is the sample Diplomat demo, and this is the one with custom, I think, Bootstrap CSS on ICU4X. So that's the whole point here, is that we have a way to take information that you already have, that you will already write for Diplomat, and you can create examples for anyone to use. So that's the whole point here. Now, here's the section where I will try to cover what you can do for us. This right here, this QR code, is for anyone who's interested in contributing. I know there was someone, I think in the back there, who is interested in Ruby on Rails. We'll get to that in a sec. If you're interested for instance, in testing out Diplomat, we're looking for users. So if you have a Rust library that you are interested in porting into many other languages, we're interested in having you test out Diplomat, but we're also looking for backend contributors. So if you're interested in, say, creating a Ruby on Rails backend or just Ruby backend, the QR code is there. And I think I'm close to wrapping up. I'm curious how I am on time. I might be way under, but that's okay. I'm good? Okay, perfect. That means we have lots of time for questions. So now the QR code is over. I want to just thank everyone who helped me with these slides, mostly from the Diplomat team. So if you see them, say thank you. And we are going to move on to questions. So hopefully I can answer some questions if anyone has them. Okay, I see. Oh, I'll let the microphones be passed around.
So one question I have, one of the goals of ICU4X also was to be transpiled into different languages. So last year, for example, they gave a demo where you can compile Rust into WebAssembly directly and then use it with WebAssembly. How does Diplomat relate into that?
So Diplomat is sort of like a way to transpile. It's the sort of automatic version that's already done for you, right? Like Diplomat, we don't create, like Rust, the Rust compiler handles creating those bindings in WebAssembly, and you can just access those if you want, but Diplomat is like a more native friendly way to do that. Like if you just want to go ahead and handle everything in JavaScript, that's a default solution for you. But if you want to do your own solution, then that's when you would transpile and create your own definitions.
So the bindings are like WebAssembly definitions that you could use as like the public API.
Yes,
let
me pull up. So like these technically, so the WebAssembly is the actual binding that's generated for this function. Everything else is what, because it's a bit of a misnomer that's saying that these other three are bindings. They're rather definitions that expose the bindings when you link your program.
Okay, thanks.
It's also worth noting that Diplomat generates the like form of that first API in an FFI safe way in the first place, because like a random Rust API, it's going to deal with various Rust types that you can't even deal with in WASM.
I had a question, which is, can you tell us a little bit more about your experience as a Google Summer of Code contributor? Maybe some things that you
Okay.
some things that, like, you know, maybe that you learned, how, like, would you recommend Google Summer of Code to other people? And yeah.
Yeah, of course. I think yes to all of the above. I think Google Summer of Code was great, mostly because I've always been aware of Unicode, like in the background, but I think once you actually start getting involved in contributing, that's how you become more aware. And so, yeah, I mean, this has been a great first project just to really test both my knowledge of like how I can work in Rust and also port things into other languages. And so I think just generally, it's a great experience. I would definitely recommend getting involved because I think it's a great way to learn. And it's a great way to learn more about a project that you may know passingly about, but you're not super familiar with.
Hi, I'm Alexei. I have a question about possible trade-offs or hidden costs. If I need to use Diplomat, what should I be aware of? So I get the nice API. I get that. So what should I be conscious of?
That's a good question. I'm mostly, when I experience trade-offs or like costs with Diplomat, it's mostly due to the result that it's still sort of in progress, like we are still sort of building things up. And so at some point you may, you know, have something work one day and then the next day it's like, well, how did this get changed? And so generally, yeah, I think if you are, I'll say another trade-off that I can think of is the simplified Rust. Like I talked about how, say, Diplomat doesn't necessarily support generics. If that's something you want, if that's something that is essential to your program structure, like say ICU4X's, what was it, date time formatting, that's something that you may want to go ahead and implement yourself, because Diplomat just we can't do that for you because we can't read how you're going to use those generics. So if you want something that you're dead set on a particular way of implementing something and Diplomat just doesn't support it, then you are probably going to be on your own for that.
Got it. So most of the things are just compile time, build time, right? But nothing in runtime.
I don't think so, no.
Right. Thank you.
There's the allocation.
Oh, yes. That's a big one. Thank you for pointing that out because I would have missed that. So one of the things that we have to deal with in Diplomat is the fact that Rust and C are great languages for, like, if you're allocating a pointer to something and then you have to free it, you can just pass that function over to someone. JavaScript does not have that sort of traditional garbage collection system, right? So what we have to do is create pieces of code that detect when a object is no longer in use. I think in JavaScript, it's a finalization registry, and then just make sure that when the lifetime edges have expired, that it is then freed. And so that is something we are still working on. It's something that is very tricky to do because JavaScript doesn't necessarily mesh well with that concept. But that would be another trade-off if you are particularly worried about memory. Any other questions?
Yeah. So how much time or effort investment would be expected if I were to attempt to do this in Ruby?
That's a good question. I think for me, because I was new to the project, it took me like about a week to get something up and running because part of my job was rewriting the JavaScript backend that we had. So it took me, I think, about a week to get it running. And then it takes just more and more time to get used to like the particular, like say garbage collection took a while because that was something that I was not exactly used to. So I would say you could probably get things working in a week, although probably even faster because I was also doing school at the time. So it's just from like that point, expanding on your feature set and what you can actually support. That's variable for me, at least.
Let me quickly jump in here. I'm Rob. I also work on Diplomat. It depends how well you know Ruby, but not just how well you know Ruby, but how well you know Ruby FFI. Because languages have variable support for calling C over the C ABI through FFI interfaces. As Tyler explained, the WASM one is very complicated, and implementing the WASM FFI, like generating the WASM code, was a lot more work than 1 week. I don't know how difficult Ruby's FFI is, but yeah, your mileage does vary there.
I was very reliant on like the previous research done by the JavaScript team because it is hopefully not for other languages, but the WASM ABI is not really well documented. So we had to do, the previous team had to do a lot of work to make sure that they understood what was going on.
My understanding of Ruby in particular is that there's a lot of there's a lot of prior art about how to build FFI based libraries in Ruby. There's a lot of Ruby libraries that are already backed by C. Like if you just go with like bundle install or gem install, whatever, like, you usually need a C compiler because there are a lot of gems that are backed by FFI. So those same types of problems. I feel like Ruby is like a more well explored area. WASM, the things that Tyler was working on is like there's not very many people who've actually looked at this problem. People mostly use like mscripton or some other high level tool for it, but not like the low level tool that we need for Diplomat. So I would say that also, the other thing I wanted to say here is that like we've done a pretty good job in ICU4X of basically making all the functions be feature gated. So like if you get like a basic implementation of a Ruby tool running, you could run like a subset of ICU4X, and then like you can continue to add on the rest of the bindings that you need in order to get the rest of it covered, based on the features that you're using in your target.
And then there will be support, right? If I start doing it, I can do a back and forth with the team if I have any questions.
Yeah, if you come to if you write a PR for Diplomat with a backend and we might like require certain things of it, and if the testing is too onerous, we might ask it to be done in a separate repo, but we're happy to like hold on to it with some caveats. And when it comes to ICU4X's published backends, that depends on the capacity of our team to keep maintaining and dealing with bugs there. But ultimately, we can always do the best effort thing of if you run Diplomat on ICU4X, it will generate the thing, and we will try to keep that tested. So it varies on how much work it ends up being on our team to keep that running long term. But overall, we're very excited to do this. So
Okay.
General, yeah.
Sounds good. Thank you.
One more question. How Diplomat is independent from ICU4X? There are a lot of questions that are like, basically, Diplomat is the way to get ICU4X across all the languages. But is there an independent future for Diplomat? And basically, if I'm building something in Rust, how easy would it be for me to use Diplomat to do the same?
Oh, it's already an independent repository. So I think I actually have an example. If I pull up, let me share my whole screen because I think it'll be easier to like demonstrate it visually. I need to present, I think, my whole screen. Okay, I'm gonna pull up, I have a repository I actually made specifically for this presentation. So give me a second to pull it up, and I'll just use it to sort of, oh wait, no, I think it's under the quick start, which I do not have installed. But here, I'll just pull up the repository itself because that's just as good. And so basically what we have in the Diplomat repository is it's its own tooling. So we have, I think under this tool folder here, yeah, under this tool folder, this is everything you need to run something in Diplomat. So when you add the Diplomat crate as a dependency, what it'll do is it will call, it can either be a library or an actual executable. So then you can call that and provide all of these arguments for the language you're trying to translate into, where you want it to be stored, any other special configuration options. And so, yeah, it's already separated. There is a tool for it. You can call it either from the command line or through Rust itself, and that's the way it'll work. All right, let me go back to presenting. Any more questions?
And also to add to that, like while the people running Diplomat have heavy overlap with ICU4X, and to some extent, like features that make things hard for ICU4X would probably be like say no to, and we might not ourselves work on things that are not as useful for ICU4X. It is extremely configurable, so quite often we've had people being like, oh, we want this for our project, and we'll add some kind of configure something. We want to be flexible. We want to support things. The Kotlin backend, ICU4X has no clients asking for Kotlin yet, so we wouldn't have added that unless we had that. We're still slow on, and we haven't really gotten to trying Kotlin out on ICU4X in a serious way because, yeah, but we have the backend in Diplomat because someone wanted to use that, and they added it, and now there are two sets of people using that, and I still review the Kotlin PRs and stuff like that, but ICU4X doesn't use it. It might eventually, but we have no current pressure to do so. So, yeah.
Okay, I think that is it for questions. So thank you everyone for coming. Let me stop presenting and I will stop the recording.